Hi, and welcome to this AI and C# video on the Microsoft 18 framework. In this video, I'm going to show you a neat trick about filtering data without passing the data to an LLM. And the reason why you might not want to pass the data is perhaps it's a big amount of data, so it will cost a lot of time and tokens, or it could be sensitive data, so you don't want it to be up in the cloud. So there's ways around this, but first let's see what the problem is in terms of speed and token count. So in here, I have a sample, and I have, if we look into the samples, it's the one on the other topics, AI as data filter. So what I have is a bunch of books, namely 100 of them, with just being some JSON. And we can see that each book have a title, a year of release, an author, a genre, and a synopsis. So I turn these books into data code here, and I put in a toString on these, so I get it out as some XML, because AI are better at XML than by the JSON. Then I make a client, and in this case, I'm using ChatGPT 4.1 Mini as the first model. And I'm just telling it's a librarian. And then I'm giving all the data in the prompt, meaning very, very long string of text. And the reason I do this is what we're about to do is not really something RAG can do, because we are going to ask some questions like, for example, how many of these books were released in 1980? How many and have an author that ends with the letter S in its name, in their name, and so on and so forth. So things a user could ask, but we can't really use anything in terms of RAG, because that's would be a similarity search that has nothing to do with these kinds of filters, or what you can call it. So I'm going to ask 3 questions. So how many of them were released in 1980? Then give how many and list the books where the authors have an S at as the last letter in their name. And finally, a bit more advanced, where have the last letter of S in their name. The genre is not fantasy and was released between 1800 and 1900. So progressively more advanced questions to the LLM. So let's first see how ChatGPT 4.1 Mini handles question 1. So we ask the question by giving the book data and the question. And we can see it came back fairly quickly, 1.6 seconds. And it says that these 2 books are the right ones. It used 4,185 input tokens, because we needed to give all the books, and output tokens were very low, because it just needed to write this simple text out. And the real answer is actually 2. But if we try again, in this case, it's still clear. I've seen it give back 3, because it thought there was 3 books. That's not the most important thing here. So let's go to some more advanced things, with the end of the author's name should be S. This will begin to take a little longer, but it says it has 27 books, the author ending, and we can already see that's wrong, because Lewis Carroll is not ending in S. Mark Twain is not ending in S. It's not even have an S in it. So it's definitely wrong with this, and the real answer is actually 15, because I'm just using a little link to check. So it definitely got it wrong, and despite that, it still used a lot of our tokens. And it goes even further wrong if we give it a much more advanced question here, like with end of author's name should end in S, it should not be genre fantasy, and it's released between 800 and 1900. In this case, it says it's 14 books. Again, it goes wrong. David Copperfield is, let's refind it. We can, for your Dostoevsky is not ending in S, for example. And the real answer is actually 7. So sometimes a model like this gets it right, sometimes it doesn't. So let's move this all the way back up here and try with another model. So now we are going in and hot reloading, so we use ChatGPT 5 Mini instead in order to do the same. So we're gonna get our 3 questions and we get the first answer back. And now it takes longer because now we are having a reasoning model and it will actually reason over what this is. And it comes back again with the same 2 books, which is good, where the other one, the ones you saw here, it could handle it, but in some cases it can't. A model like ChatGPT 5 Mini is pretty good at this, so it's okay. And if we went to one of even bigger models, it would be even better. But we are still using a lot of tokens, and now we are even using more in output due to reasoning. If we go to question 2, it now becomes much, much harder for it because now it needs to really reason over if this is right. So I've seen these take up to half a minute to run back, despite it being a fairly simple link query if you knew what you were doing, of course. But it will think about it quite a while and hopefully come back in 1 second. Yeah, it's a difficult question among 100 books. But now it comes back. And it comes back with the answer of 15, which is actually the right answer. So reasoning does help with things like this, and it's quite good at it. But we again use a lot of tokens, and now you can see we're really using a lot of reasoning tokens. But the real answer is 15. We got it right. But now let's go and do all the advanced question with both the letter S, not fantasy, and release between 1800 and 1900. I will just pause the video here and when it's back, because this will take a little long time. And we are back. You can see it for 32 seconds in order to do this. It got the answer right, which is 7, which we'll see in 1 second. But it used a lot of tokens again in order to do this. But at least it gets it right. But what I want to show you now is that there is a better way. And we can even go up here, switch back to the simple model, because even the simple model can do it in the other way I want to show you. So we're going to load up the model and we're going to load up the 3 questions. But then I'm going to jump down to some new code down here. And what we're going to do here is, instead of actually giving the model all the books, meaning the 100 books in XML format, we're instead gonna ask it to make a filter for those books. And the book filter is just, we want to have the field, the comparison operation, and the value back. So we have among title, year of release, author, genre, and synopsis. We have equals, not equal, start with, ends with, contains, greater than equal, less than equal, and regex. And then a value, just represented as a string, but we could have value as integer, value as string, but it's fairly okay to do it here. So see what happens now when I just say, hey, LLM, make a filter for the following query, and then the question. It is almost instant that it can make a filter, and we get back year for lease equals 1980, because it's an easy question now. It doesn't have all the token count, and this response, if we look at it, it only used 154 tokens. So very, very simple to do. And then, of course, it's our job to filter the books now, which I do in this, which is 2. So we can quickly go down. And this is not fun code to write, but I think it's worth getting rid of 30 seconds of wait time and 7,000 tokens by sitting down and writing this code. It can be more advanced if you have more advanced samples, of course. But in this case, I'm just going through the filters and slowly applying the filter based on what it gave back. If I let it run to here, we can ask the second question. And again, it can easily make that filter because it's really, really good at understanding what we are talking about. Because it doesn't have all the context to work with, so order ends with S. Simple to do. And again, we get the books back and we have the 15. And the final one, which is a much more advanced question, it actually goes fairly quick as well, and turn it into a filter of 4 different things. Order ends with S, genre not equal fantasy, year for lease greater than equal than 18, and year for lease less than or equal 1900. And again, we get the books, and it has the 7 books. So this is a much more advanced way. It saves a lot of time and it gives the right books back. It can tend to end up being a little more wooden answer, because now you just have the books and you need to show the answer, so that it doesn't show the normal. I looked at it and it's this and this number of books and so on. But often you want to have it in a structured format anyway. So giving it the books like we did up here is just waste of time, in my opinion, in certain scenarios. And letting it build filters like these down here, which is fairly simple to do. Then we, of course, have the annoying part of taking the filter and turn it and applying it. But it's fairly simple code. It took me like 5-10 minutes to write this code. So I definitely think it's worth doing filters instead of the system. And again, if the data had been very sensitive, we could still have used an LLM to filter it, which is really, really cool. So that is how we can do it. And thank you for seeing this video. See you in the next one.